15 years ago, Professor Robert Blake purchased the first of our Clarity UV-Vis spectrophotometers, devices for working with intact cells and other turbid media. And over the years, Bob has done some outstanding, very creative work with this instrument. And in this paper, what I'd like to just look at the moment is a sentence that he put at the bottom of his introduction, where he makes an admonishment to everyone interested in biochemical processes. Quote, "In order to fully understand and appreciate any biochemical event or reaction, one has to actually monitor the event or reaction as it occurs in real time. Simply cataloging the participants, no matter how detailed and thorough the list, isn't sufficient." So keep that in mind. Think about that. You wind up discovering things that you cannot find elsewise, because things in isolation function quite differently potentially than they do where they evolve to function. He then continues, "This laboratory has described an integrating cavity absorption meter, ICAM, that permits accurate absorbance measurements to be conducted in turbid media like suspension of intact cells," and then gives several citations from 2015, 2016, 2020, 2021. Because ferrous and ferric iron absorb light differently, the ICAM can be exploited to monitor soluble iron oxidation spectrophotometrically as a continuous process. The experimental observations presented below were conducted to quantify the rates of iron oxidation by intact cells of M. sedula. In particular, we sought to distinguish between two hypotheses: that the respiratory proteins that are responsible for iron oxidation are expressed constitutively, or that they are induced when the cells are exposed to substrate level concentrations of soluble iron. Later in the paper, section 2.3, he talks about initial velocity kinetic measurements. That's where he's using the Clarity 1000. He's also using ribosomal RNA sequence analyses and scanning electron microscopy and energy dispersive X-ray analysis as the additional methods for confirming what it is that he concludes. What he concludes, of course, is quite extraordinary, and it hasn't been seen before. So indeed, as he ends the paper, perhaps such size differences exist in many iron oxidizing acidophiles, but they have heretofore escaped notice because researchers have not specifically looked for them. It will be interesting to see whether other examples of this unexpected behavior appear in the future. So if you're interested in studying systems and reactions as they occur in real time, you would be interested in the Clarity, and I would love to talk with you about it. So be in touch.